Hey everybody, thanks for joining us today. I'm Jason Jarash. I'm the president of Nota3D, and we're going to be diving into the Figure 4 standalone and Figure 4 modular today. And I am going to share my screen here. Let's see. There we go. Awesome. So if you haven't worked with us before, at Nota3D, we're really focused on trying to create the best customer experience. And I know a lot of companies say things like this, but it really is part of who we are. And one of my sayings is, who you are is what you do. And so that's really something we try to focus on. And I believe our customers will also back us up on that as well. And what Nota3D does is nothing but 3D printing and 3D printing software. 100% of our focus and expertise is in additive manufacturing. Our team has over 45 years of combined experience in the 3D printing industry. And one thing we really like to do is focus on complex applications. So naturally, over time, we've kind of developed a specific process that has worked, time and time again. We've kind of narrowed it in. And of course, initially, we like to discuss your process and workflow, identify issues and opportunities where 3D printing could be a solution. And then once we have that, we like to dive in a little bit deeper to kind of get creative and put our ideas to the test to prove our results. And so once we can prove to you that our solution is a fit, then we'll make the recommendation. And then obviously the most critical part of the process is the post-implementation support. So we're not just going to drop a machine off and say, see you later, don't talk to us again. We like to be very proactive in our post-sale support versus reactive, which is what you typically find in most other companies. So that's really where we try to separate ourselves from others. So that's a little bit about us and how we like to work. So today I'm going to introduce you guys to the Figure 4, and we're going to dive into where it's used and why. And then we're going to have Joe Corbell walk us through the 3D Sprint software that comes with all of our machines. And he's going to kind of show you some cool features with that. And then we'll wrap up with an interview with Derek Tim from Motorola, who's a current Figure 4 customer, and he's going to talk about his current experience with the equipment and the impact that it's made on them. So, Figure 4, even though it's a very new technology, it's actually got a pretty cool story. So Figure 4 was actually thought up back in the late 80s by Chuck Hull, who is the founder of 3D Systems and the creator of 3D printing. If you didn't know, Chuck Hull invented SLA back in 1983, which was the first 3D printing technology. And in those years, he actually came up with this idea. You can see, that he was actually awarded the patent in 1991, but the actual technology to make this happen didn't exist. So the idea was there, and it basically had to sit on the shelf for 30 years before we were able to bring it to fruition. So the way the Figure 4 technology works is there's a UV projector below, and then there's a resin tray with a clear membrane on the bottom, and obviously that holds the resin. And then you have the build tray on top. The build tray lowers into the resin tray until there's a very thin layer of oxygen or resin between the membrane and the build tray, and then the projector flashes, curing the UV resin, and it's curing it an entire layer all at once. So it's not drawing it, drawing and filling like a lot of the laser-based or extrusion-based technologies. So though there are many reasons why companies do choose to implement Figure 4, there's 4 key reasons that really get people's attention when we're talking about the Figure 4. These are the reasons why most companies find that it's a good fit for them. Speed is obviously the #1 factor with Figure 4. This machine is super fast. Unlike many of the other technologies that I was kind of explaining, which is, either laser or extrusion based, they have to outline and then fill the parts. Figure 4 is actually using a projector, and it's flashing the entire layer, and that's why we can get the continuous build that's going to be really, really fast. So it doesn't matter whether there's one part on the tray or there's 10 parts on the tray. It's going to build in the same exact build time. This machine will print up to 4 inches per hour in the Z-axis, which is crazy fast compared to other technologies. And you can actually nest parts vertically to maximize throughput and print numerous iterations a day. Joe's going to kind of dive into the stacking and nesting in the vertically when we get to the software portion. But we have customers that have brought in the Figure 4, and a lot of times they would have to press print overnight, and they come in the next morning and they have their part done, and then they'd have to make a change and maybe press print by lunch, and it wouldn't be done before they left, so they'd have to wait for the next day. So Figure 4 gives you the ability to come in the morning, press print, test it, make revisions, and print the second iteration all before lunch. So that really gives you a huge advantage. And this is a great example, very relevant with everything that's going on, but rarely is speed more important than when it comes to saving lives. An Italian hospital found an urgent need for supplies when they ran out of a key component for the oxygen tubes, and the supplier wasn't able to keep up with increased demand, so they had to turn to 3D printing. The original part was brought to 3D Systems at 11 a.m. so they could get to work reverse engineering it, and by 7 p.m. they were able to present the hospital with 3D printed versions, which were successful. So production immediately ramped up using medical grade materials on the Figure 4. So that's a pretty awesome story that in about 8 hours they were able to take apart, reverse engineer it, and then start mass producing it. We'll test it, prove that it worked, and then start mass producing it on a 3D printer. So and then another huge factor for Figure 4 is the material options. So right now Figure 4 offers 13 advanced materials. We have several more slated for 2020 and 2021. Figure 4 offers a wide variety of production-ready UV stable materials that are being used for low-run production pieces. We have high-temp materials with heat deflection temps of 300°C. We also have robust tear-resistant elastomers, and we also have some great functional prototyping materials. So another thing too is we have a handful of biocompatible Class 6 autoclave capable materials as well. And then a little bit more unique, very, very niche applications, but we do have some application specific materials such as our J-Cast Green for investment casting for jewelry. And then we also have a material that is designed for eggshell molding. So that's our eggshell amber material. And what eggshell molding is it's an application where a company needs true silicone, and that's something that everyone, it's kind of been an elusive thing in the 3D printing industry, is getting a true silicone that actually functions and looks like a molded product. So with Figure 4, what we can do is we can shell out a geometry, and then we can actually print a very, very thin negative shell of a silicone part. Then you can inject the silicone, set the silicone, and then break away the 3D printed shell, leaving you with an end-use silicone piece. So, if you have applications that require a true silicone, this is an awesome way to get it for lower volumes. Since Figure 4 uses a small resin tray, this allows for extremely fast material changeovers with absolutely zero waste. So for the Figure 4 standalone, essentially all it is just removing one resin tray out of the machine, placing it into a storage container that comes with it for safekeeping, and it doesn't let any dust or light get into there. And then you pull out a second resin tray with your new material that you want already loaded in it, and you put it into the new machine, and you're ready to go. This can be completed in under 20 seconds. And our materials allow for a vast range of applications from prototyping to production, automotive to healthcare. We, injection mold plastics to eggshell molding. Figure 4 really gives you the ability to handle multiple applications and do it quickly. Plus, it's got a small footprint, so it really can fit anywhere. It doesn't require any special ventilation or any special equipment to be able to run. And then, of course, pricing is a big factor. So, we offer full turnkey packages on Figure 4 below the 30K mark. They're available to purchase outright, or we can also do leasing. And where we see leasing really fit is some companies will lease a machine, lease to own, and the revenue that they're going to generate or the savings that they're finding will exceed the monthly cost. So essentially, it's getting paid for as you go along. And you can also grow with the Figure 4. So we have the Figure 4 standalone, which is our entry level. So this is a self-pour machine, and it's very easy to run, but it's one unit. It doesn't connect with anything else. And then we also have what we call the Figure 4 modular. So what this is it's a controller. And you can see in the slide here, you have one controller, and then you can add modules up to 26 modules. And so that's going to be really great for doing low run production and really fast prototyping. If you want to be running multiple materials all at once without having to worry about switching materials, this is a great way to go. And then we also have one level above that called the production. This is a fully automated, fully customized to you, tailored to you solution where essentially you press print, it prints. There's a robotic arm that cleans the part, post-processes the part, and you pretty much just have the parts at the end of it. So we do have upgrade paths. So if you want to start with a Figure 4 standalone, we do have trade-in paths and ways to grow with you guys. So this is something we see customers doing when they're wanting to kind of get their feet wet and then move in to higher run production. Figure 4 allows for customized or personalized products because of the speed and the accuracy, and due to the production ready materials, it really gives you a customizable production. So you're seeing this make a splash in industries like hearing aids, and as you can see from the build stats, we're able to print 16 of these shells in 12 minutes, which is less than 1 minute per part, and about 14 cents per part. And then this is an area where we're really starting to see things grow, and that's low run production of spare parts or obsolete parts. So this allows companies to create what we call a digital warehouse. So they no longer have to store tools and molds for old products, and they can just store the CAD data on a server and print them as needed. So we see this a lot with like older legacy products where maybe a machine or a tractor or something is 50, 60, 70 years old. The manufacturer doesn't want to hold on to everything to make these spare parts. So this is where it's becomes really, really effective, and the parts can be chromed, plated, so you can really ramp up the spare parts business on that. Since the Figure 4 has production-ready UV stable materials along with the production accuracy, this makes Figure 4 a great fit for truly functional prototypes. So functional prototypes gets thrown out very loosely nowadays, but the Figure 4 really offers prototypes that need to go out in the field for rigorous, extensive testing, and these are parts that can provide you true feedback on what you would be able to expect from a final molded product. So, I think that's really, really important. And then following up on the functional prototypes, we also have functional rubber-like prototypes. So elastomers have always been an issue in 3D printing. Yes, you can print them, but the tear strength was weak, or it wouldn't hold up to any actual functional testing. But with Figure 4, these are significantly more robust. And still not a true rubber, but it's an incredible improvement to what else is out on the market. Here, we've compared the time and cost against PolyJet, which is another popular resin-based technology. As you can see, there's significant cost and time benefits, as well as a huge benefit in detail and strength materials. So, and then we didn't put this on the slide, but another common comparison for Figure 4 is, of course, the carbon clip technology, which has very similar build speeds. In fact, maybe even a couple minutes faster on the actual build speed, but it's significantly longer and more difficult post-processing. So your actual, time to part is going to be significantly faster than carbon, and also you can bring in a machine for about half the price of 1 year at the least. So we also have virtually no waste, and our material can sit in the tray for extended periods of time, unlike the competition that requires you to basically dump out all the material that was not used in that one particular build for specific materials. So, overall, Figure 4 is a great low-cost option. It's inexpensive to run. It's got a low price point for purchase, and it offers a really wide range of materials, fast and accurate builds. So it really gives companies a great advantage. So, and if that's something that you'd like to learn a little bit more about, if you have any interest in getting a sample part, please reach out to us after the webinar. So now I'm going to kick it off to Joe. So Joe is our applications engineer over here, and he's going to walk us through 3D Sprint. 3D Sprint is the software that comes with all of our equipment, but there are certain features that are going to be tailored to specific machines. And so if you joined our webinar last month on MJP, Joe walked through some great features on that. Now he's going to dive into some different features that are specific to Figure 4.
All right, so today we're going to just jump into modification of support structures as well as nesting, kind of give an example of what you can do with the Figure 4 as far as custom supports and things like that goes. The software does a really good job of generating the supports automatically. As you learn the software and you learn the machine, it becomes a little bit easier to kind of dictate where the support and everything should go, where you're pretty sure you're going to need it to have a successful build. So just to kind of get just a basic geometry, we can either generate the geometry, or in this case, we'll load our reference parts. It's just kind of a preset part to check the calibration of the machine. Really nice and easy. It's outlined in red, so we know it's slightly off the build platform. So we will auto place, allow Z rotation, and that'll just center it in the build platform for us. So we can see here, there's a little bit of a buffer there between the parts and the build plate. That is for our support generation. There's a number of different presets you can choose from. You can offset the tip penetration length, the single point penetration, really just a wide variety of different parameters that you can offset based on your level of knowledge or comfort with custom support generation. I'm just going to roll with the generic support structures here. Generates that, and you see we have our base, we have pillars, we have our touch points, everything you would need pretty well automatically generated. From here, we can actually click over to the Modify tab, and basically anything outlined in red here on the parts, that's going to need support. It's a downward facing angle, so that will have support on it. All of our little touch points here, these were all automatically generated across all 5 parts. We could choose to add or delete points just by clicking. Make it really easy to add. If you have a larger part that you have a fear that one of the corners might peel up, you could add support there, or rounded pieces, you could add support along the edge, make it a true round. Really minimize any issues that you might have. Once you're done, click Update Support. I have done it so many times where I've put about a half hour or an hour's worth of work into something and not hit update supports and lost it all. So don't make my mistakes. Along with adding the supports, I mentioned you can delete supports or erase them. You can choose to go point by point, just kind of delete them out one by one. Or if you want to take a quicker method, there's an outline box that you could use. Just highlight the points that you want to get rid of and just kind of get rid of everything there. Again, update supports, and on that piece, it wouldn't have support. Probably wouldn't build, it would just kind of float off into the tray. So in that case, we can highlight it again. And there's our supports again. So from here, we can take our build estimate based on the parameters we have set for the machine, 50 microns, standard build, about 14 minutes to build these accuracy blocks. You can see here the millimeter measurements on there, 28 by 25 for the big block, 23 by 20 for medium, so on. So to delete the supports, you just highlight, you'll see them outlined in blue instead of in green, press delete, and you get rid of the supports again. So with that, we often get questions, well, can I stack parts in this build envelope? Yes, you can. What it's going to do is it's going to branch off support structures from top-facing faces and just kind of add that buffer in between your parts. So an easy way to nest parts with this machine would be copy, and then under linear pattern, and kind of grow it on the Z. It only shows the first one following the line, and then dots indicating the rest of the layers from there. So it gives you a good idea of how much space you're going to have in between parts, and you can offset that by changing the distance. For this, just going to leave it as it is. Try 10 layers. We could probably go even more. 14 is too many. So we'll do 12. So we set that, they all stack. Really nice and simple way to nest. From here, we'll generate the supports. Yes, a single support can be generated for multiple parts if combined. Do we want to combine the parts? We'll say yes, because the parts are stacked in this case. Highlight our parts, close these out, and create supports. So once the supports are generated, you can see here pretty easily, everything's really well automated. You don't have to adjust any of the support structures here. You can by going back into our modify, and you can see all of our little touch points. We hit update supports. And if we hit update supports again, it'll just bring all those back for us. So really a nice hands-off or hands-on, depending on what you're looking to do with your parts. So they make this software really simple. If you want to be hands-off, you can. Here, instead of just the one layer, now we have multiples. You can do this with different parts. It doesn't need to be just the accuracy blocks, or it doesn't need to be just one set of parts. You can copy your entire first layer up to the top. The software does a pretty good job of grabbing everything you would need, building everything the way you would need it. So if we take another estimate, instead of the 14 minutes for the one layer, now we have 13 stack for 2 hours, 42 minutes. And that's a pretty easy way to nest the parts for a figure 4. So along with nesting on the figure 4, something else you could really do to maximize your efficiency with the machine is to offset the build parameters. Right now, like I pointed to earlier, I have the 50 micron standard build. We could actually bump this up to 100 microns, since we know the vertical surface finish is not an issue for these parts, and we can build it in draft mode. So I believe we had 2 hours, 51 minutes, 2 hours, 54 minutes. It's going to ask us to regenerate the supports. In this case, we're not going to, because we know everything's going to come out well. So I'll leave everything as is for the support generation, and I'll run our estimate one more time. And we cut our time in a little less than half. So that's pretty darn good. Going from the 2 hours 50 minutes down to 1 hour 45. Roughly the same material use, but really saving a lot of time there. Effectively doubling our layer height and moving from standard build mode over to draft mode. And at that, I'm going to kick things over to Derek Tim from Motorola Solutions.
For the last portion of our webinar today, I would like to introduce Derek Tim of Motorola Solutions Applied Technology Group. Derek has been instrumental in the product development and prototyping activity at Motorola for 6 years and was involved with the evaluation, justification, the purchase and implementation of 3D Systems Figure 4 3D printer. Derek, thanks for joining us today and sharing the challenges of your responsibility at Motorola and your experience with the Figure 4. I'm sure many of you out there joining us share similar obstacles to what Derek may encounter in your companies. Derek, could you tell us a little bit about what you and your staff does at Motorola and how 3D printing has benefited that activity?
Yeah, sure. Thanks for having me. Here at Motorola Solutions, the Applied Technology Department, we focus more on unique solutions for our customers. So our volumes tend to be much smaller. We're not selling millions of products. We're selling, from 10 to 100. So we really need something that can prototype very quickly because every problem is very unique. So 3D printing has really come in and helped us in that area. We used to, have to go out and machine each part and check it one by one as we iterated. And now that we've moved to 3D printing, we're able to do that on a scale that we never did before. And this new printer especially has really escalated that speed as well. So where we used to be able to 3D print either in-house on our own machine or out of house in a matter of a couple days, now we're able to do it in a matter of a couple hours.
Wow. It sounds like providing really fast, extremely detailed components to shorten that iterative design process are the biggest parts of the service you guys provide to the engineers there and your customers. How did those demanding requirements influence your decision to buy the Figure 4?
So we previously had a different printer. That printer was an FDM printer. It allowed us to print bigger fixtures and things like that, but it was really lacking in that fine detail, like you mentioned, and things like living hinges, rubber parts, none of that could be done on that printer. So previously we relied on other companies to do our printing to accomplish living hinges, rubber buttons, those type of things. When we set out, maybe a year or so ago, we were looking for a printer that could do those things that we were not currently capable of doing in-house. So that's when we reached out to you guys and we saw that, the Figure 4 had a lot of the things we were looking for. It had a very large material selection to choose from that included, ABS-like materials, rubber materials, those type of things. On top of that, we really love the speed. So our current FDM printer, it does okay, but if you have a 2 or 3 inch tall build, it's going to take, multiple hours, 5 to 8 hours to complete. So we were still only able to iterate about once a day at best. This new printer, allows us to iterate 3 to 4 times a day or more. So that's where we're really seeing a lot of benefit from this.
So it sounds like limitations and shortcomings in your previous systems really drove the decision to bring in the Figure 4.
Yes, definitely. Yeah. We were just limited with things like snap hinges. We just couldn't do those before. Like I said, we had to rely completely out of house, and with procurement and stuff, that takes 2 to 3 days to accomplish that. So, and it's much more expensive than printing in house. But for us personally, the biggest challenge or obstacle we were facing was just a time aspect. So if we were to iterate, say, a clip or something, we just could not trust the FDM printer because of the way that it prints. We couldn't trust the snap fits. The detail just wasn't there. So we would have to rely on going out and printing multiple times, getting parts back and checking them. And it was a rather slow process even by 3D printing standards. So we really wanted to bring something in, that would allow us to do that in-house. And that's where the Figure 4 has really accomplished that goal.
Oh, good. There's a number of OEMs that produce machines or 3D printers out there. Did the fact that 3D Systems was the OEM on that machine, they manufactured it, and Nota, you're going to be your support company, did that influence your decision at all?
It did. So, we do a lot of research on 3D printer companies that are available, and we attend a lot of the seminars and the conferences and stuff for those.
Right.
Two of the big names, one is 3D Systems. They were one of the bigger names, and so we had a lot of trust with that company. I know big Motorola, so we're, Applied Technology, but big Motorola has had talks with 3D Systems and stuff, and they have some of their machines. So we were very comfortable using them. We knew that they had good support and they've been around. So, you're
Right,
getting,
right.
a quality product. So
Okay,
that's
good.
where we first started looking. And so we brought you guys in, and it's been perfect ever since. So
Good relationship.
yeah, yep.
Over the last year, you had your machine. I'm sure you've done numerous projects. Can you share maybe some details about some of those projects or any of the projects?
Yeah.
And how the Figure 4 really helped?
Yeah, I'll point to one in particular. We had a project where we had to create a battery door that slid on, think of like a remote control type device. So you have a battery door at the back that slides over and it snaps. Typically, that's not an overly complex part, but in this particular design, the space for that battery door was barely bigger than the battery itself. So we had very, very little room to work with those clips. So this 3D printer really became instrumental in printing multiple iterations and multiple styles of clips. It's the Pro Black 10 material that we use is very good for living hinges, which is really crucial because we need it to mimic, very closely to polycarbonate, what the final product will be built out of. And so like the FDM printer that we have in house, it can't mimic that. If you snap the thing on, it will literally snap the clips off. And so this material is very flexible, and very closely mimics.
Like this one?
Yep. Yeah, exactly. So we were able to use that material to really dial in this hinge, and it's a very complex little hinge, but, probably through, I'd have to estimate 30 or 40 iterations that we ran, but it really only took probably 10, maybe 2 weeks worth of time to dial up, where normally that would take us in the past, 6-7 weeks, just because we have to deal with vendors going in and out. So that's where we really saw a huge benefit, was just the time and being able to, print, change right on the fly. So I will point
with all the materials available on that machine, I imagine you switch materials occasionally. Is that something you do, and what materials do you prefer?
Yeah, definitely. We started with just the basic gray material that they have. It works fine and stuff for prototyping, but we quickly realized that the Pro Black 10 is really what we wanted to do everything in. So we pretty much use the Pro Black 10 as a base material. We print parts that we're going to be using in housings, other stuff. It just has a lot of great mechanical properties, being, temperature and flexibility and stuff. We've also, the other material that we've used a lot and have gotten a lot of use out of is the elastic material. Like the one you just held up there. Yep. We print gaskets in that and buttons. And typically we have to mold those. And with 3D printing, until this came out, we really didn't have a good way to test those ahead. So we relied heavily on just design specs and previous experience, and then we'd go mold those. But very often we molded those, got them, and they were too tight or too stiff, and we ended up actually reworking the tool, which is quite costly to do.
Right.
Right off the bat, the first project I had, we printed some buttons in it, and on top of just being really good to show customers for demos because they look and feel like a real, rubber button. It also, on the back end, really saves on that molding time.
Yep. You mentioned gaskets. Are you running fluids through your parts?
No, typically it's more for waterproofing. So.
Oh, waterproofing. Okay.
Yep. Yeah. So we'll run like a gasket, and it's normally at the EM, level. So we end up still molding those gaskets. But for the initial evaluation of it, we'll 3D print those gaskets in there. A lot of our specs don't necessarily have to be IP67, but they do need to be water repellent. And so,
Okay.
we go through, like a spray test and those type things. And
Yeah.
this really allows us to quickly turn gaskets, where normally that would be kind of a more difficult process.
Oh, good, good. What about larger parts? I imagine occasionally you have a request for a larger part. How do you handle those types of builds?
Yeah, I gotcha. I know the machine does have the ability to split the parts and create a larger part. We haven't used that a ton yet, but what we do right now is typically our parts are only large in one direction. So normally we're not printing, an 8x8 block of anything. Normally
Right.
you have something that's, maybe a half an inch by 4 inches by 8 inches. And so
Okay.
in this setup, we just tilt it on its axis. It actually prints better in that direction anyway.
Oh,
And so
good.
that's how we've really been handling all the big parts, is to just tilt the part in the machine. So, yeah.
Good, good. So anyway, to sum it up, what would you say the main benefits to Motorola
Mhm.
that you've realized as a result of having that machine, the Figure 4?
Yep, time more than anything.
Time.
We are very much up against the clock to turn products as fast as we can in this line of work, and this printer has really come in big on that. So, like I
Good.
mentioned, with buttons and just housings and just even engineering models, we are able to really showcase parts and test parts much quicker than we were before. So,
Okay, great. Well, Derek, thanks again for sharing your experiences with me today.
Yeah.
If any of you out there have questions for Derek, send them in. We'll get you an answer later in the program. And again, Derek, thank you so much.
yeah, thank you. Thanks for having me.
Okay, we'll see you.
All right, awesome. Well, thanks guys for sticking around, and I hope you guys got some good information out of it. We do have a couple questions that I'll run through real quick, and actually we have a handful, so we'll see what we can get through. But so one of the first questions was, does XY placement affect tolerance capability? Is there an effect for being further away from the center, which I presume is the focal point? So I think this really plays more true to a laser-based type of machine. I guess there is a limit, right, on a projector, but so the answer is no. There is no tolerance effectiveness based on where you place it further from the center. So the reason why the Figure 4 build tray is the size that it is because 3D Systems in development figured that was the optimal size to have the highest tolerance. And so in 3D Systems, if you kind of look across all of our technology, high tolerance, detail, accuracy is usually our number one priority, and materials, right? So we don't put out machines that are not accurate, and so sometimes that limits us on certain things like build tray size. So but yeah, so that was the long-winded way to say no. It doesn't matter. You can place anything on the tray, it's going to be just as accurate anywhere. So another question we have here is, you had briefly touched on carbon comparison. Can you elaborate more? So yeah, so I can kind of go into this a little bit further. So carbon, great machine, not dogging it, but it definitely it has its fit, right? So there are areas where carbon really is a production machine. Like that's what they want you to do with it. You want to basically program the machine to run one part, and you just run that same part over and over and over and over again. And then if you have two parts you want to do, you buy a second machine and you just sit there and design that one to that one. So whereas the Figure 4, it gives you a lot more control, right? So you don't have to, if you're going to be doing a lot of different geometries, a lot of different parts, the Figure 4 is very forgiving. It gives you a lot more control, and that's typically where we see it being a better fit. Obviously, price-wise, you know, I think the carbon machine's somewhere around $50,000 per year for 3 years, and you either got to give the machine back or you renew. You know, figure 4 is below 30, you own it, and you can just go from there. And then another big factor is material waste. So you know, it's common that you have to well, and it's material specific, but you know, with carbon, the material, it's the 2-part epoxy materials that they don't sit well, right? So it's basically you have to fill the tray, you build your part, and whatever's left in that tray has to go, and then you have to refill it again for the next build when you're ready to go. Figure 4, that's not the case. Our materials can sit in the tray for weeks at a time. If they're going to sit there for a while, there is a little stirring tool that asks you to kind of stir the pot a little bit before your next build. But otherwise, you know, there's no waste. You don't have to throw anything away. You know, and then post-processing is very simple. Our support structure is essentially a tearaway. The supports, it's a scaffolding support similar to others, but more like a webbing. You just pretty much tear it off. You clean the part in you know, isopropyl alcohol, and then you're going to put it into a UV cure for anywhere from 45 minutes to 90 minutes, depending on which material you're running. So you're getting your parts pretty fast. So I mean, we can dive more into it if you have more questions, but those are kind of the main comparisons there. And so it looks like I think that is it for questions. If anyone has any other questions, oh, there's a new one that just popped up. Do any of your materials contain flame retardants? I don't believe so, but let me, we can try to find out some more information about that, but not off the top of my head, I don't believe that we do have a flame retardant material right now on the figure 4. So I'll double check that, but that's my initial gut. Oh, another question came in. What durometer rubbery materials are available? So as of right now, we have a Shore A65, and then we have, which is our Elasta Black, and then we have our Rubber Black, really creative names here, Rubber Black 10, which is going to be a Shore A97. So it's fairly rigid, but it's really, really tough stuff. I mean, I've tried to tear it with my hands, and I mean, I can do it eventually, but it's a struggle. So, but yeah, so it's going to be a little bit more on the higher end there, but they are working on some newer materials as well that should be coming out fairly soon. So if there are not any other oh, and I see a comment here too from Lisa, who she's with 3D Systems. I think she's based out of Texas. She did make a good point here for the person asking about flame retardant materials. We do have that on SLS. That's an awesome technology. I believe that's actually what our next webinar is going to be about. So if you want information on that, let us know. So thanks everyone for joining us. And if you have questions, reach out to us. We'd love to talk more, get some samples, and see what we have that might be a good fit for you guys. So thanks everyone, and have a great day.